Well, hello everyone, and welcome back to my channel. Today I'd like to talk to you more about balancing chemical equations. What are balanced chemical equations? Why do they need to be balanced? And how do you go about balancing them? So let's begin by answering a question: what does it mean for a chemical equation to be balanced? As I said in the previous video, a balanced chemical equation obeys the law of conservation of matter. In other words, the total number of atoms on the reactant side of an equation must equal the total number of atoms on the product side of the equation. An equation that does not do that is unbalanced and does not have a whole lot of use in the world of chemistry. Here we have a wonderful chemical equation for the decomposition of water. That's right, you can take water and split it back up into hydrogen gas and oxygen gas. It's actually pretty easy to do. It can be accomplished in any chemistry classroom. You won't get a whole lot of hydrogen and oxygen gas out of it, but it's still kind of neat to do anyway. So here we have the equation that represents that. Here's water as the reactant, and then a chemical reaction occurs and it transforms into hydrogen and oxygen. Criteria number one for a good chemical equation is that it must have correct formulas for all reactants and products, and these formulas here are all accurate. Everybody knows the formula for water. Hydrogen is in fact H2, pure hydrogen gas. Oxygen gas is in fact O2. The second criteria is that it must be balanced and obey the law of conservation of matter. This one, as it is written right here, right now, is not balanced. Well, what do you mean? Well, to demonstrate that, let me use some coins to represent atoms and molecules and whatnot. There's a quarter, and that's going to represent oxygen. And here are a couple of pennies, and pennies are going to represent hydrogen atoms. That's right. So let's review. Pennies equal hydrogen atoms. Quarters equal oxygen atoms. So this model that I've constructed here represents water. Looks like Mickey Mouse. That's right. Looks like Mickey Mouse. Anyway, let's now use these models and show what would happen if we took this one molecule of water and were to break it apart into hydrogen and oxygen. Okay, so water molecule breaks apart. And whoops, the two hydrogen atoms come back together and bam, form H2. And now the oxygen atom, but wait a second. We got a problem here. Got a problem. The product is supposed to be O2, but the one water molecule only has one oxygen atom and therefore cannot form O2. This is what we mean by an equation that is unbalanced. The left side of the equation, the reactant side, has one atom of oxygen, but the product side shows two. Well, there are not enough oxygen atoms on the left side of the equation to make the oxygen on the right side. So what do we do about this? Do we get Hermione Granger to come here and cast a spell with her wand and poof, make another oxygen appear out of nowhere? No. Okay? This is chemistry and not Hogwarts. Chemistry is real and Hogwarts is fake. Get over it. So what do we do? Well, what we do is we balance this equation. How do we go about balancing that equation? Well, you might be tempted to just stick a 2 right there. Okay, yeah, just stick a 2 right there, and then it'll be 2 oxygens on each side of the equation. Wrongo. Can't do that, okay? This is the equation for the decomposition of water. You can't just go change the formula of water. Not permitted. Sorry. Hashtag not sorry. So what do we do instead? Well, there's something missing from this equation that will make it balanced. And the thing that are missing are these numbers called coefficients. Coefficients are numbers that appear in front of the formulas in a chemical equation. Okay? And what do those coefficients do? Well, they represent or tell us how many molecules of each substance are involved in the reaction. Your job as a chemistry student is to balance an equation by adding coefficients where they go in such a way that will make this equation obey the law of conservation of matter. Now, right now, technically speaking, each of these formulas that you see here all have a coefficient of 1. That's right, 1 molecule of oxygen can make 1 molecule of hydrogen and supposedly 1 molecule of oxygen. In the world of coefficients, a 1 is invisible and understood, just like in algebra. In algebra, you wouldn't write 1x, you would just write x. The x by itself implies 1x. Our job then is to add coefficients to make this balanced. Now, I'm going to show you how to balance an equation in another video, but for this one, I'm just going to balance it right away and then show you how it works, show you why it is now balanced. So a coefficient of 2 belongs in front of water, coefficient of 2 belongs in front of hydrogen, and the invisible 1 is all we need for oxygen. Let me get some more coins here. Let me go to the bank and make another withdrawal and do another demonstration to show you how this is now a balanced equation. Okay, so this 2 that I wrote in front of the water means it takes 2 water molecules. 1, 2 water molecules. And now, if I were to break apart these water molecules and attempt to assemble what is here, I could do it because this is a balanced chemical equation. So I'll start over here, O2. Can I assemble an O2? Yes, I can. There's O2. What about H2? Well, I can assemble H2, and I can assemble H2 twice. And that's what this big 2 in front of it, the H2, means. The 2, this large 2, means H2 2 times. There's one H2, and this is another H2. So as you can see, let me walk through that one more time. I was able to create all of these reactants with these models, and then from these reactants, I was able to create all of these products. Every single atom that is here right now ends up being used on the product side. No atoms were lost, like I didn't throw any coins away. No magical atoms were brought in by Hermione and her magical spells. This then shows the law of conservation of matter. In the next video, I'm going to show you how to decide what coefficients to put in front of different formulas to make an unbalanced equation into a balanced equation. But for now, I say to all hand, which means have a nice day.